Shakti ma'am, shall we start?
Yes, Bindu ma'am. We can start.
Okay, okay ma'am. Good evening, respected dignitaries, esteemed speakers, and enthusiastic participants. I am Bindu. I am delighted to welcome you to day 2 of our International Faculty Development Program on Futuristic Pathways in Technology and Computational Methodologies. Yesterday's session set a high benchmark with profound insights, and today we are excited to continue this enriching academic journey. To formally commence today's session, I invite Mr. S. Vinod Pandian, Assistant Professor, Department of Computer Science, to deliver the welcome address. Sir, over to you,
Yes.
sir.
Yes. Good evening, one and all, esteemed delegates, participants, and distinguished guests. On behalf of the Facibate Association and the Department of Computer Science at Mary College of Arts and Science, it's my pleasure to extend a heartfelt welcome to you all for the second day of our International Faculty Development Program. I trust that day one was a fruitful and insightful experience, providing valuable insights and fostering a vibrant exchange of ideas. Today, we embark on another enriching journey as we deeper into the cutting edge advancement shaping the technological landscape. Once again, welcome you all. Thank you.
Thank you, sir, for your warm and inspiring words. Next, I call upon Mr. D. Bakiraj, Assistant Professor, Department of Computer Science, to introduce today's distinguished chief guest. Sir, the stage is yours, sir.
Thank you, ma'am. Respected dignitaries, esteemed participants, and dear colleagues, good evening to everyone. It's my privilege to introduce the chief guest for today's session of our International Faculty Development Program, respected Dr. P. Shanmugavadivu, Senior Professor in the Department of Computer Science and Applications at Gandhigram Rural Institute, deemed to be University, Dindikal, Tamil Nadu. Ma'am, Dr. P. Shanmugavadivu is a passionate educator and a distinguished researcher with over 33 years of teaching experience and 23 years in research. Her exemplary contributions to academia include guiding 10 PhD scholars, mentoring numerous MPhil candidates, and publishing an impressive body of work in international journals and conferences. She has also authored 3 books and contributed extensively through 21 book chapters and 5 edited volumes. Her innovative spirit is evident through her leadership in securing over rupees 2 crore and 40 lakhs in funding research projects from esteemed agencies like the UGC and DST, and her contributions to cutting-edge areas such as medical image analysis, artificial intelligence, and healthcare data analytics. Respected Dr. P. Shanmugavadivu's global engagement is reflected in her international visits to countries like Malaysia, the USA, China, and Thailand, where she has shared her expertise and collaborated on academic advancements. Our chief guest is a recipient of several prestigious awards, including recognition for her Indo-US project on employability skills. She continues to inspire with her dedication to teaching and research. She has delivered 260 invited talks at national and international levels, making her a sought-after speaker in her field. Dr. P. Shanmugavadivu ma'am has demonstrated exceptional administrative expertise as well. She has served as Dean, School of Computer Science and Technologies, Head, the Department of Computer Science and Applications, Member, Board of Management, Member, Planning and Monitoring Board, and Director, IPSC. Our chief guest is also a lifetime member of Indian Society of Technical Education and Center for Education Growth and Research. Today, she will enlighten us on the topic the potential and prospects of generative AI, an overview. Generative AI represents a significant frontier in technology with the potential to redefine creativity, problem solving, and innovation across industries. Ladies and gentlemen, please join me in welcoming our esteemed chief guest, Dr. P. Shanmughavadi, ma'am. Ma'am, welcome, ma'am. Thank you. Over to MC.
Thank you, sir, for the detailed and thoughtful introduction. Ladies and gentlemen, it is an honor to invite today's speaker, Dr. P. Shanmughavadi, Senior Professor at Gandhigram Rural Institute, Dindigul, to deliver her session on the potential and the prospects of generative AI, an overview. Ma'am, we eagerly forward to your insights, ma'am. The floor is yours. Welcome, ma'am.
Thank you, everyone. Pleasant good evening to every one of you. I thank Mr. Pakiraj for all his words about my academic journey. And I also thank the organizers of this international faculty development program, which is working on so well. My special thanks to Shakti, my thanks to Bindu, and all other faculty members who are involved in this organization of this workshop or faculty development program. It's indeed a kind of pleasure to get associated with Mary Mother College because this is the second chance that I have to work with them. And earlier, in the first encounter was like I was invited for an international conference, as it was mentioned by Mr. Pakiraj, and the whole day the experience was very pleasant. And when there was a call from Shakti, I thought it was going to be a one-to-one faculty development program in physical mode. Then they said it is not physical, it's online. So all the participants, when you get a chance, please go visit Mary Mother College. You will enjoy the ambience there. So I did enjoy it. So you'll also have an opportunity to do that. So I thank the organizers for this wonderful opportunity to get connected to the academic fraternity who is really interested to learn about the latest technologies in computer science. With this brief note, let me get into my session content. And with your permission, I'm opening up my slide for the presentation. I totally understand all of you must be having a lot of thirst to do research by using latest technologies, right? So when you have that kind of inspiration or thirst, then it is essentially important to learn the latest advanced technology so that it becomes ideally unique, and also you travel with the advancements and the changing paradigms and changing technologies so that you'll be able to show yourself in a better light when you look into this aspect in terms of academics or research. Once again, and let me open up my PowerPoint presentation. I hope you're able to see the slide that I have presented.
Yes, ma'am.
Yes, ma'am, it's visible, ma'am.
Okay, thank you. Dear participants, now this session is going to be on generative artificial intelligence, and now my focus is on highlighting the potential and prospects of generative AI. And this is a kind of an overview that you can have, and then you'll be able to understand the purpose of generative AI and what are its potentials, what are its prospects, what are its applications, so that you will be able to integrate this interesting technology into your research or academics or education as you like. So this is the roadmap, a brief introduction about generative AI, then types of generative AI, then prospects, applications, potentials. Now, it wouldn't be justifiable if we don't start with the definition of artificial intelligence, because artificial intelligence is the mother of all the inventions that is happening in the current scenario, and generative AI is one such amazing technology. So, to give a very brief definition about artificial intelligence, it's a branch of computer science that deals with simulation of intelligent behavior in computers. So, as you could do thinking, as you could do prediction, as you could classify, as you could have perception, as you can have vision. Now, whatever that is possible with the support of a human brain is possible with the wide range of array of algorithms, models that we have in the name of machine learning, deep learning, this generative AI, GAN, and we have a very long list to talk about. So for all this kind of innovative technological upsurge, artificial intelligence is the key technology. So it's needless to mention that it's a branch of computer science that deals with ideal simulation of intelligent behavior of human being in computers. So it is the capability of a machine to imitate intelligent human behavior. So now there arises a question, what do you really understand by intelligent human behavior? Like when you look at an object, we are able to recognize. And if it is not familiar to you, you are not able to recognize. So you just make a decision whether you are aware of that object or not, number one. Then we are able to make some kind of perception about a person or about an event or about a situation. This is what you call as same thing could be done with the support of computers as well. Then we can take decisions, then we can go for recommendations, then you can rationalize. All those things that we could do only with the support of human brain is possible with the support of artificial intelligence. So, as again, the definition goes as artificial intelligence is a technology that can perform tasks that traditionally only human could perform. So this is the kind of key term that we have to keep in our mind. So whatever that you could do by applying human brain is possible even beyond the limitation of, beyond the potential of human brain. We are able to perform better with the support of artificial intelligence. So what is the role or what is the place of generative AI in the context of artificial intelligence pie chart? See, now artificial intelligence is not a kind of standalone technology like that can just emerge on its own. So this is a kind of, it encompasses lots and lots of small chunks of technologies all put together is called as artificial intelligence, or under the umbrella of artificial intelligence, we can talk in terms of computer vision, then robotics, machine learning, deep learning, predictive artificial intelligence, expert system, fuzzy logic, conversational AI, and top of all these things, the latest intrusion of technology in the name of artificial intelligence is generative AI, generative artificial intelligence. So before we move to the next slide, let me just take the pleasure of reading what is the definition of artificial intelligence in terms of literary definition of artificial intelligence. It's a technology, it's a noun. AI is a noun. It's a technology that can perform tasks traditionally require human intelligence. That's a very simple definition. So now let us turn our attention towards generative artificial intelligence. Traditionally, artificial intelligence or its subset, machine learning, is meant to perform three things or three approaches, I could say. One is supervised, other one is unsupervised, and the third one is reinforcement learning. I think every one of you, if not most of you, would be aware of the differences between supervised machine learning, unsupervised machine learning, and reinforcement learning. Each gives insights based on a clustering output. See, now I'll just give a brief intro about the supervised, unsupervised, and reinforcement learning for the benefit of those faculty members who are not really clear about the distinction between these three categories. So as the name suggests, supervised learning deals with you give the input as well as output to the model. For instance, if you talk about a medical report, right, we give all the symptoms about, for instance, a breast cancer or lung cancer, and then we give the concluding remark like whether that patient is down with a kind of cancer or not, or if a person is a healthy person or unhealthy person, is the person is record is perfect or imperfect. So we have to provide both input as well as output data to the machine learning model, and the model will be able to establish a mathematical relationship between the input data and the output data. For instance, if there is patient X, then the patient might be having a set of symptoms. So now there are a set of symptoms based on which a doctor, a physician, an oncologist would be able to come to a conclusion whether that patient is down with a kind of cancer or not. So how does it happen? The doctor understands the relationship between different symptoms that have been recorded for a particular patient or for a person, and accordingly they come to a conclusion. So there is a relationship between the input parameters, I mean the symptoms, right, disease symptoms, based on which we make a decision. So as we try to correlate the symptoms with respect to identification of diseases, we want the model to understand if these systems are present, what should be the conclusion, what should be the inference, what should be the understanding, what should be the output. So based on which, if the process happens, then it's called as supervised learning. So what do? We supervise the model to understand what are the symptoms to identify or to predict whether disease is present or not. And hence it is called as supervised. So when we go for weather prediction, when we go for disease prediction, when you go for predicting the share market price of a particular commodity, or whatever that you do in terms of prediction or some kind of regression, right? For the given set of data, you produce the output. In all such kind of problems, we tend to apply the supervised model, because for the given set of input, you need the output. So what do? We take a model, for instance, there are a set of machine learning models like linear regression, a logistic regression, decision tree, Bayesian classifier, support vector machine. So these are all illustrations of supervised machine learning model. So we have to provide a data set that contains both input as well as output. Point number 1. Then point number 2 to be noted is you have to split the data set into a training data set and testing data set. The proportion can be 50-50, or it can be 60-40, or it can be 70-30, or even it could be 80-20. So first of all, we split the data set. You give the training set data. It can be 70%, for instance. So I try to feed in 70% of the data set that I'm dealing with to the model, for instance, Bayesian classifier or support vector machine or decision tree. The model tries to understand the relationship between the input parameters values and the target parameters value. So now it is able to come out with a kind of mathematical relationship between the input and the output. For instance, suppose if you have a set of values, so you have X value and Y value. At this point of time, I want to draw your attention regarding what's the difference between dependent variables and independent variables. So dependent variables, all the input parameters are being referred to as dependent parameters or dependent variables, and the output parameter is called as all the input parameter values are being called as independent, and the output parameter is called as dependent. Because suppose if a patient has to be diagnosed for a fever, for instance, so then the doctor will check the temperature, body temperature. Then the doctor will check whether a person is having running nose or not, cough or not, what is his level of systolic, diastolic pressure, and then the doctor will try to find out as many symptoms as possible to come to a conclusion. So these symptoms that you call as input parameters are totally independent, right? So depending upon the body condition, you get you get to show up the temperature or any kind of ailment symptoms. So these parameters in any kind of given data set, for that matter, the input parameters are always called as independent parameters, and the output parameter is called as dependent parameter, because based on the conclusion that you draw on the input parameter values, we come out with the output parameter. So that is called as dependent. So the value of the output parameter depends on the input values. Well, so what happens now? You just split the data set, let it be 70% or 50% as you like. But you please remember, when you work with the problem, we have to check and find out what is the optimal level of splitting. Does your model work with respect to 70-30 proportion or 80-20 proportion or 60-40 proportion? That should be done by means of trial and error. And now I have taken 70% of the data set and I have given the data set into the model. It is getting trained, right? So when it is getting trained, the model tries to understand the relationship between the input parameters and the output parameter. And then it comes out with a mathematical representation that is called as mapping function. That is very simple to understand. I'm going to put it this way. It is y is equal to f of x, right? Y is your output parameter, which is dependent parameter. It is a function of x, where x stands for set of input parameters, set of independent parameters. So the model is going to come out with a mathematical relationship between x and y, which is expressed as y is equal to f of x. Well, so once we finish with the training process, then as usual, we will measure the performance metrics like accuracy, then loss function, and then we go for precision, recall, sensitivity, specificity, confusion matrix, F1 measure, all the things we compute. Now, the understanding is we have trained the model with the given data. And then we have to verify whether the model which has performed well in training could do the same with respect to testing also. Now what do? We remove the output value and then try to make the model to predict the output for the test data. So then we compare the predicted value with the actual value. Then you go for the computation of accuracy, then error rate, all those things. So the point to be remembered here is, in the case of supervised learning, right, you do the training process, testing process. At the same time, when you select the data set, right, and most of the research scholars miss this point. Whenever you take a data set, first of all, you have to check whether the data set is perfect in every form, right? So for that purpose, you have to perform exploratory data analysis, right? That is shortly referred to as EDA. It is exploratory data analysis. So you have to perform this first and then check whether the data set is perfect. Only then, if you are convinced that the quality of your data set is perfect for machine learning, only then you can start with this machine learning process. Otherwise, what will happen? Now, if the teacher is good enough, then you can expect the student to perform well. And suppose if the teacher is going to give some kind of junk information, the student will not be able to learn properly. So in the similar way, when the data set that you give for testing or training is not good enough, then the results will not be good. So due care should be taken when you decide about the data set, its quality, as well as its distribution. So with this brief introduction, let me move on to unsupervised learning. Now, there are some occasions you may have data set for which you don't have to predict the output. Rather, you just want to classify them, or you want to cluster them, or you group them. In such cases, it is called as unsupervised learning. So there are certain models like K means K nearest neighborhood, that is KNN model is a typical example for unsupervised classification. So in this case, we will not have at another target component to be called as that independent variable. It is just, we are just going to work only with a collection of data and grouping. Suppose if you are given a data set of different kinds of teachers who are attending this faculty development program, then you can go for clustering. You can just group with respect to the college from where the faculty members are attending this program. So we try to cluster them based on the similarity, and we try to separate them based on the dissimilarity. So this is what you call as unsupervised. There is no need for supervision. So this model is called as unsupervised. Then the reinforcement learning model is the one. Now we allow the model to perform in the best possible way by training and testing. And after you finish the process, you check whether the model is performing well or not. And if it is working excellently well, then it is given a component called reward. And if it is not performing well, and it is given a component called penalty. It is not like a materialistic kind of a presentation or kind of punishment. Rather, it is adjusting with the weights of each and every parameter. All of you must be knowing. Now, when you work with these kind of models, each model will be given some kind of weight based on its significance. So this reinforcement learning works with respect to feedback mechanism. Now, based upon the output, every time we tend to fine-tune the model so that it will be able to work in the best possible way. I think enough of this description about machine learning. So now these kind of AI models are being called as non-generative AI model, right? Please note this keyword. Now, the machine learning models that you are dealing with, say linear regression, logistic regression, decision tree, then support vector machine, Bayesian classifier, these kind of models are examples of non-generative AI that makes calculations based on input, right? Why? When I give a data set of, lung cancer data set or cardiac data set or diabetic retinopathy data set, it just works only with respect to that data set. But now the focus is on generative artificial intelligence. I think every one of you must have experience with Chat GPT, right? And it is working excellently well. You are not providing data set, you are not providing any information, you don't enrich its knowledge. All that you do is just give a query on which you want the data to be generated. That happens beautifully in the best possible way or beyond your imagination. So these kind of AI models that we are dealing prior to this generative AI are called as non-generative AI that make calculations based on input like classifying an image or translating a sentence. Now, in contrast, generative models produce new outputs such as writing essays, composing music, designing graphics, and even creating realistic human faces that do not exist in the real world. I think all of you must have heard about this DALL-E. You give description in the textual form about an object, it will be able to create a visual for that. So that is possible. So let us start with the simple definition of generative AI. Generative AI is a type of artificial intelligence that can create new content. Underscore this, it creates a new content that has not been given by the end user. It does it by itself because it has been trained in such a way so that it will be able to create any kind of content, right? Suppose if you have a genius in front of you, you ask any questions, the person will be able to answer. So this is mimicking a genius who knows about everything. Right, so that has been simulated in the form of generative AI models. So new content such as text, images, music, and even videos. It learns patterns from the existing data and generates new outputs that resemble the original data. Right, it as if someone sits and then writes an essay. It comes like this. So at this point of time, I just want to know, like, is there any kind of queries to be clarified or dear participants, if you have any specific question at this point of time, before we move on to generative artificial intelligence, I'll be happy to handle your question.
Good evening, madam.
Good evening, sir.
Could you please give one example for reinforcement learning, madam? Some real-time example so that I can understand that better.
Okay. A real-time example is like teaching a child to memorize a poem, for instance, or an essay, or a kind of content that you write and give, right? It can be memorizing a paragraph, or it can be reciting a poem, or reciting a rhyme. Just take this as an example, right, sir? Now,
Okay.
now we are asking the child to recite it. If it is perfect from the beginning till the end, what do we do? While training the child, she or he is having a competition in 2 days' time, and we are giving training at home, right, for the recitation. If the child is performing well, what do? We just appreciate. We give a pat on the back. You are doing excellently well. Keep it up. Then the child will understand the child is on the right track, right, and he or she is doing in the expected way. So they will stick on to that pattern, and then they just proceed for improvisation, right? And suppose if the child makes a mistake, it may stammer, it may pause, or it may murmur, or it may repeat a word again and again. In such cases, what will be our response? We say that you are not doing good at this point, at this sentence. Now, at this portion, your performance is not good. You're just prompting. And probably we may give a beat also. See how many times I am telling, you're not listening to me. So now the child understand it is not doing well, and hence it has to go for improvement, right? That is what we mean by giving a beat or giving a pinch or something. So the same thing happens in the, so this example clear to you, sir? So that
Yes, I got the example.
Okay, sir. Now, what do? We take the model and then we train the model, then you get the result. Suppose if I expect 98% accuracy. So then what happens? I'm very comfortable and I'm satisfied with this 98% accuracy. Then in the feedback mechanism, we say that it is doing well. So that is done with respect to reward. So the set of weights which has been assigned, which have been assigned to the input parameters are taken note of because they have given the best result. Second time, when we go for a second kind of learning or second iteration, what happens is it may not give better results. Now, again, that is noted. Now, that means that the kind of weights that we have given for the input parameters are not ideal or not good enough. So we have to go for refinement. So that has been taken care by means of penalty. What happens is the weights are getting adjusted. So like this, it goes through a cycle of refinement through rewards, penalty, until we reach the targeted accuracy or targeted error, very minimum error or the maximum accuracy. Am I clear to you, sir?
Yes, madam. Yes, madam.
Any other clarification, please? Thanks for opening up, sir.
Thank you, madam. Thank you.
Okay. So any other question? If not, in absence of any questions, I'll just proceed. Okay. So here we have to keep in our mind the key points: learning from data. Then it deals with creativity and originality. Then the third one is ease of usage. Because when we talk about this ChatGPT, right, you don't have to put in any effort as such. As such, what happens? You just click onto it. Is the slide visible to you all?
Yes, visible, ma'am.
Yes, ma'am.
Okay, thank you. Thank you for the response. So these are three key points. It learns from the data, generative artificial intelligence. So how does this ChatGPT is able to give results for any kind of questions that we raise? Any guess? Any guess from or any answer from the audience, please? The participants rather. See, when I ask about artificial intelligence, it is able to give. When I ask you from physics, it is able to give. When I ask in chemistry, it is able to give. When I ask something in mathematics, it is able to give. You just ask anything, it is able to. How does it happen?
Ma'am, it was trained.
Hello?
It was trained, ma'am.
Training on what? You're correct. You're perfect. Training on what?
Supervised learning, ma'am.
It is this kind of learning. Actually, when we talk about generative artificial intelligence, we don't talk about, because this machine learning deals with now this generative AI. When you enter into this domain, it is called as deep learning, right? So under deep learning, we don't have the supervised, unsupervised, semi-supervised, or reinforcement learning. You're getting the point. So here, it is only collecting information from vast amount of data, which is of videos, images, audio, text, and many possible sources. So the developers have collected voluminous data from different sources in different modality, and then they have trained the model to extract the necessary information based on our queries. Okay, so I hope you remember. You must have or just flip through the encyclopedia, right? You can find some references or some information on any kind of topic that you want to know. In the similar way, it's one book, encyclopedia, which gives information about various subjects. In the similar way, you have got a digital repository of data. I think one of the participants. Yes, thank you. So it's a digital repository, digital data set, which is highly voluminous beyond our imagination. So the models are trained to grab or to extract the relevant information to your query or to my query, and it summarizes the whole thing into a proper format and presents it. So that is what our ChatGPT does. So now let us see what is the scope of this in the light of its prospects and potentials. So that is why we have this point. The first point is learning from data, right? So generative AI learns from vast data set, allowing it to adapt and generate diverse content based on patterns that it identifies. Okay. Then it has the component, namely creativity as well as originality. Unlike rule-based systems, generative AI can produce content that goes beyond predefined rules. Because why do we talk about this predefined rules? When we talk about or when we develop an expert system, a rule-based system, it anchors on this predefined rules, right? So the model will not be able to think beyond the set of rules that we have given in the case of non-generative artificial intelligence. Whereas in the case of this generative AI, it goes beyond the predefined rules. Hope you're able to get the grasp of it. So showcasing a level of creativity comparable to human-generated content, right? Suppose if you're conversant with general knowledge, right? You can write an essay or you can write a paragraph on any given topic. In the similar way, it is able to exhibit creativity as well as originality on par with human intelligence and human ability. The third aspect is ease of use. Generative artificial intelligence is making it possible for anyone to learn new skills and knowledge quickly and easily, because anybody can learn anything nowadays. Recently, my research scholar came from Bangalore, and what he said was like his daughter, who is in third standard or fourth standard, she doesn't require any assistance from her parents for learning, right? Whatever be the doubt she has, Then she gets it cleared with the help of ChatGPT. She learns everything by herself, and then she's very independent in learning, right? So this is made possible with the support of generative AI. So this is making it possible for anyone to learn new skills and knowledge quickly and easily. This is creating new opportunities for people to upskill and reskill, and it is making the workforce more adaptable as well as resilient. Okay, so what are the simple examples that we can think of in the light of generative artificial intelligence? Image creation with realistic details, then text generation with coherent and contextual relevant outputs. These are very simple examples. Generative AI can do much more than what we think. So this timeline will quickly help us to understand what is the evolution that has taken place right from the year 1962 to till date. See, now they just measure the performance or scope of computation with respect to number of parameters which have been processed by all these kind of models. So this is very interesting to see. In the year 1962, they developed an artificial neural network that we shortly call as ANN, which was capable of performing computation with respect to a maximum limit of 1K parameters, that is 1000 parameters it will be able to handle. But even in the year 1962, handling 1000 parameters is not a small thing, right? It's a kind of big deal. Then in 2006, right, then AWS is being launched, then NVDA releases CUDA architecture. So all these things helped the computers to gain better computational ability, better storage, better compatibility. So then next in the year 2009, then ANN, they have got combined, this ANN, then NVDA, GPU designed for matrix mathematics operations. Then in the year 2012, this AlexNet was released, right? This wins this ImageNet competition. This is AlexNet was the winner in the year 2012. Then from this point onwards, deep learning revolution starts. So the deep learning revolution is kick-started in the year 2012. And now you can see the difference. There is a big jump, or the computational potential could exhibit a very large leap from 1K parameters to 60 million parameters. You can imagine the kind of difference or the kind of massive transformation that has taken place in computational potential. In the year 2015, deep reinforcement learning, this AlphaGo, is the first model, which was deemed as first better than human model. This AlphaGo was able to prove to the world the potential of deep learning. In the year 2017, then transformers were introduced, then multi-headed attention. See, my dear friends, those who are very serious about, very conscious about quality research using artificial intelligence, you please try to explore what could be done with this attention mechanism. This can give a new flavor to your computation so that you will be able to show some novelty on your research by using this attention mechanism. So this attention mechanism was a breakthrough in the era of computation, especially with respect to artificial intelligence. Then this paper from DeepMind was released. In the year 2018, you could see from 60 million to it has gone to 117 million parameters. In 6 years' time, it was bifold increase with respect to the parameters. Then at this point of time, BERT also came out. What is BERT? It is bidirectional encoder representation from transformers. So what do you mean by transformers? Shortly, we will be able to throw some attention into this transformers. Now, in the year 2018, GPT-1 version was released, and then there was no looking back. Then the potential of parameters or the dimension of the parameters were exponentially increasing, right? There was a larger scale progression with respect to the parameters. So from 117 million, it has gone to 1.5 billion parameters. Now it is 10x in 1 year. Now we have got this GPT-2. Then in the year 2020, we got the release of GPT-3. Now the potential is 175 billion. Now this is 100x in again 1 year. Then in 22, GPT 3.5 was released. Then they started using generative AI revolution begins with ChatGPT that has been introduced. So then 2023, this MSFT announces ChatGPT in communication, Bing, etc. Then Google responds to MFST about BART-based Lambda. I think you can all Google and see what is meant by this Lambda. It is very interesting to learn about all this kind of revolutionary changes which are introduced by all these kind of models, right? So you can have a quick look at this timeline also. I just leave it to you. You can just see this. It is a kind of another representation of the previous slide. And may I request you all just to have a look at this before we move on to the next slide. Okay. So here the new thing which is introduced is NLP, natural language processing in the year kind of 2030. Then the next one is sequence to sequence models. Like in the case of natural language processing, we go by reading word by word, right? That is what you call as sequence to sequence learning. Then when transformers were introduced, there was a provision to encode, decode from both directions, as we talked about BERT. And let us discuss about all these things in the coming slides. Then LLM, large language model, is again a transformative technology which has brought in lots and lots of changes that we could never foresee in the light of generative artificial intelligence. So now let us quickly have a grasp on this conversational AI and generative AI with respect to key features. Now, in the case of this conversational AI, you can go for developing a model which can understand natural language processing, as you have got apps with the help of which you can translate from one language to another, or you can understand one language and try to summarize it. So all these things. Then this is natural language processing understanding, speech recognition, dialogue management. These are all the examples of conversational AI. Generative AI, it is content generation, creative versatility, and then learning from data. These are all the features of this generative AI. So now we are going to compare them with respect to focus and objective, input and output, application and use cases, training and data learning. Well, so this conversational AI primarily focuses on enabling human-like interactions and providing useful responses in conversation. As simple as that. See now, when we talk about this conversational AI, scope is limited, right? Whereas as we talk about generative AI, the scope is unlimited as far as possible. So then it takes input in the form of natural language and provides relevant and context-aware responses. Here takes either structured or unstructured input data and generates new content based on the learned patterns. Then about this applications and use cases commonly used in virtual assistants, customer support, and language translation applications. Now it's applied in the case of on the other side, that is generative AI. It is applied in content creation, art and design, virtual reality, as well as gaming, right? Then regarding the training data and learning, it is trained on a large data set containing human conversation, users' queries and responses. Whereas here, for the generative artificial intelligence, it is trained on various types of data like text, image. This is the main difference that you could see with respect to machine learning model that is non-generative AI and generative AI. Now here we just use voluminous data as well as multimodal data, which can give lots and lots of information that is useful for generating the content for ChatGPT or any kind of generative AI. So text, images, or audio to learn patterns as well as generate content. So as we look into this slide, we can understand, So AI is the broader umbrella under which we have got this machine learning, deep learning, and neural network. Now, this deep learning neural network can have two major classifications under deep learning. One is LLM, large language model. Other one is generative AI, ChatGPT, as well as BART. Generative AI versus traditional artificial intelligence. The characteristics we have taken: AI, traditional AI, and generative AI. So let us have a clarity about all these things with respect to two components: purpose as well as data integration. So we are able to develop computer system that can perform tasks that typically require human intelligence. That's what you call as artificial intelligence. So with respect to this machine learning models, we can make predictions or make decisions based on the given set of data. But what happens with respect to generative AI? This generates new data samples and resemble the given set of training data, right? So we do not know what is the training data, but based on the query, it is able to get the relevant information and produces it. Data integration. Models use various techniques and strategies designed to mimic human intelligence across a wide range of applications. What happens with traditional ML? Models learn from data, as we discussed in the beginning: supervised, unsupervised, and reinforcement, and make predictions or decisions on new unseen data. But here, with respect to generative AI, models produce new data that weren't part of the original data set, but share similar characteristics. Because what do you mean by this point? Now, when I give a query to ChatGPT about the basics of generative AI, this question is not present in the data set, right? Only data is present. It is able to look into the similar data, connect it to my query, it takes them all out, it summarizes and brings it. Okay, so then with respect to generative AI and LLM, let us draw the difference between generative AI, LLM, and the special capabilities of large language model. It is worth mentioning in the flow of this content. So generative AI, it is a broad category of AI that uses machine learning to create new content, and it can be text generation, image generation, and code generation. Now, LLM, it's a type of generative AI that uses massive amount of text data to understand language and perform tasks. So these are the examples: BART, GPT-3, Llama are the examples. But what are the special capabilities of LLM? We can write creative content. We'll be able to answer questions. We can translate language. We can summarize factual topics. All these aspects could be taken care of. Then, what are the examples? Writing poems, generating codes, scripts, musical pieces, informative answers, translation, summaries, and many, many more. How does generative AI work, right? Now, these are all the steps which are being followed when you go for generating the model: data collection, training, latent space representation, generation, and iterative refinement. I would request you to pay some attention to all these things. This will give you an insight about how the data is being accumulated to produce results by the ChatGPT or generative AI. So this Gen AI utilizes advanced algorithms, typically based on deep learning and neural networks, to generate new content. Underscore this: new content based on patterns and examples from the existing data. So what happens? The first step is data collection. So a large data set contains examples of the types of content the generative AI model will generate. Okay, so this data collection is a depiction of a large data set that contains examples of the type of content generative AI is expected to generate. So now they have decided what should be the scope of ChatGPT, right? So based on the scope, based on its potential, based on the expectations on the performance of ChatGPT, for example, I'm just taking this as an example, they must have accumulated large amount of data that you call as large data set. Then we go for training. The generative AI model is trained on the collected data set, as happens in the case of training, right? The trained generative AI model creates, second point. The generative AI model is trained on the collected data set. This typically involves deep learning, specifically generative models like GAN. This is worth learning about this GAN. This GAN has got a lot of potential in terms of research. I request you all to explore the research aspects of GAN, right? So that shortly GAN to be expanded as Generative Adversarial Network or Variational Autoencoder VAE. So during training and model, the model analyzes the patterns, structures, and features of the data set to learn and understand the underlying characteristics. So as we train the children to read the alphabets and then to pronounce the words, to pronounce the sentences, it just goes on and on. The same thing happens. So latent space representation is being created. The trained generative AI model creates a latent space as we take notes, right? Suppose if the content runs to some 10 pages, to have a summarized kind of notes, you take note on the very significant salient points from the given content. In the similar way, the trained generative AI model creates a latent space representation, which is a mathematical representation of patterns and features it has learned from the training data. As we talked about the supervised learning, where you have got this mathematical relationship between the input and output, what here it does is for the data that it understands, it creates some mathematical notations. Okay, so I'll come again, which is a mathematical representation of the patterns and features it has learned from the training data. This latent space acts as a compressed abstract representation of the data set, as simple as taking notes. So then we go for a new data generation. Because it generates new data, it is called as generative artificial intelligence. So using the learned latent space representation, the generative AI model can generate new content by sampling points in the latent space and decoding them back into the original content format. So now with it has been encoded, then it should be decoded. Encoding, decoding process goes on. So then there is a necessity for iterative refinement, wherein generative AI models are often trained through an iterative process of training, evaluating the generated output, and adjusting the model's parameters to improve the quality and realism of the generated code. Because every time it goes through a kind of refinement, self-learning mechanism, so that when you do the next search, probably after 10 or 15 days, there will be a kind of improvement. As our knowledge gets improved, as our knowledge gets sharpened through training, same thing happens with respect to ChatGPT and generative AI models as well. So this process continues until the model produces satisfactory results. So this process is being followed, right, to generate any artificial intelligence model. Okay, how does it work? It takes text. These are all the input data for the generative AI model. It can be in the form of text, it can be in the form of images or speech or structured data, 3D signal, and many more. So these data set are being used to train the model. This is the foundation model. Okay, so from the foundation model, we can go for generating question answering pattern. You can have a kind of chatbot, or you can go for a sentiment analysis model, or it can be information extraction, or it can be image captioning, object recognition, instruction following. So these kind of things could be done. So this is the time to talk about types of generative AI. There are 4 major categories about the generative AI: transformers, autoencoders, variational autoencoders, and GAN, generative adversarial network. Let us see one after the other. So the first one, autoencoders, are the fundamental type of neural network architecture used for data compression and feature learning. So what are the application? Data compression and feature learning. So this is the structure of your autoencoder. There are 2 levels, right? So this is layer 1, layer 2 for encoding, and there are other 2 layers for decoding. So whatever with the input that you give, that is getting encoded, it is able to create a latent space representation. Then based upon the query, it creates a code, and then it is able to give the output based on decoding process. This consists of an encoder that compresses the input data into latent representation and the decoder that reconstructs the input from the representation. So because it might have a latent representation in the form of mathematical notation, but when it gives the result or when it responds to our queries, suppose if I ask a question, summary of generative AI to ChatGPT, it cannot produce the result in the form in which it is represented or understood internally. It has to give in the form that I can understand, in the form of a summary or in the form of a text information. Hope you are able to get my point. So autoencoders, use cases and applications. You can use it for image denoising. Autoencoders can remove noise from images during the reconstruction process. Then dimensionality reduction. This is one of the most important applications of autoencoders. They can go for compression. That is, when you have a very large voluminous data, suppose if you have a data set with 100 input parameters, then you can reduce it by going for this autoencoder. Autoencoders are employed for reducing the dimensionality of data while preserving the essential features, right? Then anomaly detection. Suppose if your data contains some unwanted outlier exterior points, that can be taken care of by means of anomaly detection. Autoencoders can detect anomalies by reconstructing normal data and highlighting the deviations. So they can come out with anomaly detection. Simple example, autoencoders find applications in identifying anomalies in network traffic data, helping to detect the potential cybersecurity threats. So autoencoders can be used in cybersecurity applications. So as the name suggests, this is a variation over the autoencoder. So this is called as variational autoencoder. Now, are the class of generative models that operate on the principle of encoding as well as decoding. And here we have got neural network for encoding as well as decoding. So there is one set of neural network for encoding and one set of neural network for decoding. So they consist of two primary components, an encoder network and a decoder network. The encoder processes the input data and converts it into latent space representation. So here we have got this red dots are the latent space representation, while the decoder reconstructs the original data from its representation. Okay. So variational autoencoder introduces a probabilistic element allowing the generation of diverse outputs rather than a single deterministic one. Encoder, latent space, and decoder. Okay. See, can you see here? That's input network is there. And then you have got this encoded data. Just 1 minute. Just give me a 1 minute break. 1 minute. Now we will be able to see here. There is one network for encoder, there's another network for decoder. So they consist of two primary components, an encoder network and a decoder network. Encoder network given in kind of blue bubbles, and reconstructed, that is decoder network, in the form of mustard colored bubbles. Now, the VAEs introduce a probabilistic element allowing for generation of diverse outputs rather than single deterministic one. So this is the feature of it. Okay, use cases. We can use it for image generation, anomaly detection, data imputation. So image generation, VAEs are widely employed for creating realistic and varied images, finding application in the field of computer vision as well as graphics. Then anomaly detection, same as that of autoencoder. Due to their ability to learn normal pattern, VAEs are efficient in detecting anomalies or outliers in dataset. This is very interesting. Data imputation. Suppose if there is some missing data, and if some data is missing for some reason or the other, we can employ this variational autoencoder to fill the missing data points in the data set, making them valuable for data pre-processing as well as completion of the entire task. An example, in healthcare, VAEs have been used to generate diverse medical images for training AI models while preserving the patient's privacy. Now, for instance, I want to develop a medical diagnostic model for which I want large volume of image or data set. In such cases, but I have only 1,000 images in my hand. Now, this variational autoencoders will come into our rescue. We will be able to generate lots and lots of new images, new data, so that your data set becomes larger, and so the learning process becomes more deeper. The third one is transformers. Transformers are commonly used in NLP, natural language processing tasks such as translation as well as text summarization. It excels in capturing relationships and dependencies in data across long ranges. See now, suppose if there is one sentence that should be understood, then it is easy for a first standard child to learn. And suppose if you ask the child to read a chemistry book or physics book, it makes no senses. So for that purpose, like first of all, the model should have knowledge about it. And in addition to that, we should see the relationship between what is the what is the association of the first sentence with the last sentence of a single page. So that is what you call as dependencies of data across long ranges. So it uses unique architecture called self-attention mechanism. I made a mention about this attention mechanism when we talked about year-wise details. So it uses unique architecture called self-attention mechanism, which allows it to process information in parallel and capture long-range dependencies between words in a sentence. Okay. So here, what is the structure like? You have an encoder, you have got a source input, and then you have this attention mechanism given here. So this source is being taken. Here there is an attention mechanism, and then we do have encoder layer, decoder layer, and decoder layer also we have this attention mechanism, and then you get the output probabilities, right? This is very interesting to work with. I would suggest you all to explore this kind of models with respect to your research domain. So use cases for transformers, language translation. Transformers are used for high quality language translation and machine translation models. Okay. So then transformers contribute to generate descriptive captions for images. This is very interesting, right? There will be, you can give an image by looking into the content, by looking into the model, it will be able to give caption to the image. Transformers can do that. So text summarization, transformers are applied for creating concise and informative summaries of text documents. So example, in natural language processing, transformers power chatbots, language translation services, and text summarization applications, demonstrating their versatility in handling various generative tasks. So now let us focus on this attention mechanism before we move on to the potential and prospects of generative AI. First of all, let us try to understand what is meant by this attention, right? What is attention? When you pay attention, that means that there are a good collection of events or good collection of persons, good collection of objects, but you focus only on the object or the person or a situation or an event that interests you. right? That is what you call as attention. So when you have a large amount of data to take a decision or to make a prediction or to do a kind of classification, I don't need the entire data in my hand. Rather, only I need a special set of information, very significant, very information carrying features or information significant data. So if I have 100 parameters, I don't want 100 parameters, I just want 10 parameters based on which the decision can be taken. So attention mechanism is the one that deals with when you have data in your hand. Instead of using all the data in my hand, I don't do that. Instead, I just take into consideration the most important data based on which the decision can be taken. To identify the best and most important significant data, we use this attention mechanism. So now let us turn our attention towards this attention mechanism. A transformer can be summarized as an encoder-decoder model with an attention mechanism, because already we have seen here encoder-decoder with attention mechanism. So generative models face challenges. So here, generative models face challenges of not just processing data, but understanding the intricate relationship within it to produce meaningful and coherent outputs, right? So attention mechanisms are the linchpin, right? They are the one which help us to identify which is the most significant important data in addressing this challenge, bringing a human-like ability to selectively focus on specific elements of the input data set, right? Suppose if there is a question, I have been to Delhi, right? I was in Delhi during the last 10 days. During my vacation, I have been to Delhi. Now there is a question, right? Which place did you go? This is the question. So what should be the focus? The place is the focus. So I can say that 10 days back, I started from Dindigul. I traveled by air. I reached this place, so on. So then you just look out for the place that is where you went or where you stay. That is only Delhi, right? So in the similar way, depending upon our queries, we are able to identify the most significant word or input or feature, which is done with the help of this attention mechanism. So now, mimicking human cognitive process like selective focus, attention mechanism draw inspiration from how human process information. Much like human naturally focus on specific aspects of a scene or a conversation, attention mechanisms enable AI models to selectively attend to crucial part of the input data and not the entire set of data. So cognitive efficiency, human cognitive processes are efficient because attention is not evenly distributed across all sensory inputs. Similarly, attention mechanism ensures that computational resources are directed towards the most relevant elements, optimizing the model's understanding and generative capability. So now this is a simple information about this attention mechanism, or just to make you understand what is meant by attention mechanism, how it really works. You can just look into the aspects of your attention mechanism as it is depicted in this diagram. So you have got these key components of attention mechanism. So you have got three components: query, key, and then value. Okay, so now here you can see Q for query, K for key, and V for value. Query stands for, represents the information the model is seeking or querying, and then the key is the one represents the element in the input data, that is the input that you give. The value represents the most important the importance and the relevance assigned to each element. That is a kind of giving weightage to it. So what is attention score? It is going to calculate the attention score. Attention scores are computed to determine the importance of each element in the input data concerning the query. This calculation is typically achieved through mathematical operations such as dot product or neural network layer, because neural network also works on dot product and summarization and summation. Okay, so for this purpose, we have to make use of softmax function. This transforms attention score into weights, ensuring they sum up to 1. So as you could understand, summation of WI this is how you write price equal to 1 to n, summation of y is equal to summation of I is equal to 1 to n xi into wi. I mean xi dot wi. So this is how you represent a neural network. So in the similar way, the softmax function transforms the attention scores into appropriate weights for each and every input component, ensuring they sum up to 1. These weights represent the model's focus on different elements. The one which has got more focus will have more attention score, less significant will have less attention score. Weighted sum. The final step involves taking the weighted sum of the values, right, where the weights are determined by softmax transformed attention score. So attention score is computed, given to each and every input, and then it is able to find out which is the best one to look into to get the best results. So this is a kind of simple example that I just want to show you. Right, you have got the bar is loud, right? So it just takes one after the other. It applies attention mechanism. This is how it goes on and on to come out with the result that you want to find out. Because this word bark, right, there is a kind of ambiguity. Bark may refer to the noise made by the dog as well as the outer coat of the tree. Both are the same. Unless I embark on the word loud, I may not be able to conclude the bark refers to the noise made by the dog. So this is what you mean by attention mechanism. Now, where is the attention? Attention is on the word loud. Only then I'll be able to interpret the bark as a sound. So these are the types of attention mechanism. First one is self-attention, second one is global, and the third one is local attention mechanism. So let me just throw some light on each one of this. Self-attention mechanism is called as intra-attention, right? So it's a mechanism that allows the model to assign different weights for different components of the input data, input sequence. So unlike traditional attention mechanism, self-attention considers the entire input sequence simultaneously, enabling the model to capture dependencies between elements regardless of their position, right? So you can try to understand this. Self-attention mechanism deals with providing different weights for different input depending upon its seriousness. Okay, so when you have this kind of mechanism, it is called as self-attention mechanism. This weightage is being given, and this is how it goes on. This is a simulated version that you can even find in there. So here the key features are simultaneous processing. Self-attention processes all elements of the input sequence simultaneously, making it highly parallelizable. Parallelizable is like you take each and every input, parallel it is being processed. So what is the speciality of this model? It is able to capture long-range dependencies. The model can capture long-range dependencies between elements, which is particularly beneficial for tasks requiring a broader contextual understanding. So versatility, self-attention is versatile and can be applied to various types of data, including text, images, as well as sequence of input data like text. So now the second one is called as global attention mechanism, wherein you just take into consideration the entire data set. So involves considering the entire input sequence, but with varying degree of emphasis on different parts. So unlike self-attention, global attention assigns different levels of importance to different elements, providing a more focused view on the input. See, now in the previous one, we have taken only each and every data set is being taken. Within that, you try to provide weightage. In the case of this, you take the entire data set. For each data item, you're going to provide weightage based on which you decide which one will have better understanding or better significance regarding this entire process of operation. So key characteristics, variable emphasis allows the model to focus more on specific part of input sequence while still considering the entire context, not the local one or self-attention one. Flexible weights, the attention weights are dynamically adjusted based on the relevance of the each input element with respect to the current query. Thereby, it is able to provide adaptability. The third one is local attention focuses on specific region or subset of the input sequence at a time. And unlike global attention, which considers the entire sequence, local attention zooms in on a limited neighborhood, right? Suppose if it is with respect to, for instance, within a sentence, right? If we have a very long sentence, we don't consider the entire sentence as we have in the case of self-attention. Within that, we try to freeze the focus. We try to converge, or we try to minimize the focus to a specific area so that it will have more attention than the rest of its contemporaries. So in local attention is placed on a few source states, not on the entire one. So what are the key characteristics? Spatial constraints restricts the attention mechanism to a specific region, reducing computational load associated with considering the entire sequence. Enhanced efficiency, particularly beneficial when deals with long sequences, as it allows the model to attend to relevant portions without being overwhelmingly be influenced by the irrelevant information. So this is global versus local attention mechanism. You could see here in the case of attention layer that focuses on the entire set of data, but here this is only, you can see here with respect to this. Now we have taken into consideration the entire data set, and this is your attention, right? And in this data set, as you could see, now this is your attention, and then this is done with respect to the local neighbors and not unlike here, the global set of neighbors. See, now let us proceed further with potentials of generative AI, where we talk about we can create visual content, we can go for audio generation, we can go for text generation, code generation, and this generative AI use cases deal with synthetic data generation, as I made a mention with respect to medical data, knowledge management, collaboration, that is human-machine interaction, then enterprise search. Like these are all the possibilities which you can have with respect to that. So in addition to that, right, now we have got generative AI use cases. You can do coding, codex, then WaveNet, Whisper, Stable Diffusion, DALI, Deep Dream, GBT, Midjourney. You can Google on each one of this and try to see. And I would suggest you to give these as the assignments to your students. Let them make a presentation. You can learn from them, and also we can make them learn, right? So generative AI use cases and applications. Then what are the potential areas where we can apply? In finance, not even a single field is left out without the application of, without covering the application of generative AI. Finance, entertainment, healthcare, manufacturing, real estate, tourism, insurance, legal industry, retail, as well as logistics. See, you can fix your research area and see. So another perception about this generative AI in a different perspective. So visual content, audio generation, text generation, code generation. So visual content, you can go for image enhancement, video prediction, 3D shape generation. Then audio generation, music composing, TTS generator, STS conversion. Text generation, creative writing, chatbot, translation, code generation, code compilation, and bug fixing. Now, recently, one of my scholars, my scholar had written a code in MATLAB, but he wanted to work in Python. He wanted to write a code for support vector machine. So he was just telling me, like, ma'am, it is a big task. I have to learn Python, and then like I have to write code for, because I told him, you when you want to work with the model, it's better to code by yourself and see understand the code. Only then you can make some corrections. So when we were discussing, I just made a mention, why don't you try with ChatGPT? Probably it may generate code. So instantly, without wasting a single minute, he sat in front of the computer and he just gave Python code for support vector machine. You just won't believe. It gave the entire code in no time. So this code generation, code compilation, bug fixing is child's play nowadays with the support of generative AI. This is fair attention. So what is the need for generative AI in education? Now, in the next generation, the education is going to be thoroughly fueled by generative artificial intelligence, wherein we have got scope for personalization, personalized learning, engagement and interactability is going to be very high when compared to human teaching. Then it is going to have the component of adaptability, and its efficiency and accessibility is going to be multifold. Then it has the feature of creativity and innovation. Fostering inquiry spirit in the student is going to be tremendous. So what are the benefits of generative AI in Salesforce, right? In terms of sales, it is going to again help them to have better personalization of their entire business. Then definitely the productivity will be enhanced. Then scalability of business is also possible with the support of generative AI, and it has the assurance for flexibility. Then real-time assistant, 24/7, 365 days. And once it is done, it is going to be permanent. You don't need any other cost investment. That helps in cost cutting. And in terms of computational efficiency, it is 100%. So these are the 6 key themes shaping the future of generative AI. And the first one is LLM, large language model evolution. Now, I would suggest you to explore the research potential of large language model. That'll really help you to focus your attention on how best you can work on this kind of large language model. Then computer scarcity challenge, right? Now, suppose if as I said, right, suppose if I am not able to generate or write code using Python, right, for SVM, or for or any other model, right? Then this code generation becomes very, very simple and easy. Then the third one, that is called as orchestration layer development. This is a very interesting point to discuss about. Now, this is like you have a model on which you will be able to build the rest of the component. This is like, suppose when there is an orchestration that is going on, right? Then there is going to be one orchestrator who will be able to control the entire process with respect to different instruments, then the singer, and then the other persons, like they'll be able to take control over the entire operation that goes on the stage when an orchestration is going on. In the similar way, the generative AI has got a component called this orchestration layer is the one that is able to integrate, that is able to coordinate, that is able to manage the rest of the operations that can take place with respect to generative AI. Then open source momentum. Now, most of the software are being released as open source. That helps the users to gain access over those kind of software and integrate them into their day-to-day affair and activity. So that helps them in a larger way to turn their attentions to get inclined to the usage of open source momentum. Helps us to use the newer software without investing or without the constraint on the cost. Then this guardrail for ethical AI, this is the most important one. Now, when we are using this generative AI, then we lose track about the ethical aspects which are related to this artificial intelligence, right? So it is essentially important that we must be able to have ethical considerations. The do's and don'ts of usage of the generative AI should be is the major concern, and a lot of attention has to be given right into this arena. Then multimodal AI advancements. Now there are a lot of, it is not MODEL, that model deals with different algorithms. This is multimodal, deals with different types of data that you use when you want to work with a model, right? When you want to have a mechanism for problem solving, you can use text, you can use audio, you can use images, you can use data, and hence you will be able to harness the potential of all this kind of different data models so that you will be able to have the best result out of different types of data sources, right? So that is the essence of this multimodal AI advancements. This deals with modality of data, not model. So the generative AI, the applications in terms of medical, because I'm working in medical image analysis, medical diagnosis, then I just wanted to highlight this as well. This medical simulation, Gen AI technology, medical simulations provide healthcare professionals with an efficient setting to practice and enhance their skills. Suppose if a medical student wants to know about the functionality of this entire human system or any other system, living organism, then they have to rely on 2D images, or they can go for simulation. But with the support of the generative AI, they'll be able to have better ambience, better choices to learn about all this kind of medical simulations. Medical chatbots use NLP, natural language processing, to assess the symptoms, suggest steps, and even notify healthcare providers to improve access to care and optimize the healthcare resources. The third one is tailored treatment plans. Generative AI analyzes an individual's health profile, including lifestyle choices, existing medical conditions, to provide a better quality of life for patient. Then the fourth one is disease diagnosis. Generative AI enhances the accuracy and efficiency of interpreting data, extracting insights from physical records, patient histories, and diagnostic reports. This is what you call as multimodal mechanism, right? Then physician's record, doctor's record, patient's history, and diagnostic report, facilitating for precise, accurate diagnosis. Then drug discovery predicts the effectiveness and safety of novel medications to reduce the time and cost of drug development. So these are all kind of happening research, medical simulation, medical chatbot, tailored treatment plans, then disease diagnosis, drug discovery. These are all examples. Then major applications of generative AI model in healthcare. There will be a kind of overlapping between this and the previous slide. Diagnostics, drug development, personalized medicine, medical chatbot, training medical professionals, then language translation, medical transcription. Now, we don't have to have a person to sit and then do the transcription that happens from the USA to India and then forth and back. Everything could be done by means of Gen AI. Then medical imaging, elimination of administrative tasks, generation of synthetic medical data, then population health, then neurotechnologies, then telehealth improvements. These are all the upcoming opportunities that we have. Then challenges of generative AI in healthcare. The most important challenge is privacy of the patient. So patient's data privacy has to be preserved, right? You cannot have it as a transparent data. So limited high quality data, the available data dimension is very less. And then potential biases. Now, suppose if I have a data set which belongs to the Western countries, then that kind of symptoms may not work well when I use the same model for Indian scenario. So then whatever that has been done in the form of training will have a potential bias, because there is a lot of potential variation between the data that you see for a single disease from different locations. The need for compliance regulations, because we have to think about how best we can make this adaptable, usable, practicable. These are all the challenges which are ahead of us to be addressed by us. Then integration with the legacy systems, because we have to make everything legal. Suppose something goes wrong or when something adverse happens, then it should be answerable in legal terms, and it should be legally manageable, legally handled. So this is another one. Then accountability, because we do not know when you generate content using ChatGPT or when you use generative AI, you cannot fix the responsibility with anybody or anything. Suppose if there's a doctor who sits and does the diagnosis, if something goes wrong, you can point your finger to him or her, say that now your diagnosis has gone wrong, so I have got this kind of problem. But when it is generative AI, like, you cannot fix the responsibility with anyone because it's a kind of general model. So, but anyway, these are all the aspects to be considered. See, whenever there's a challenge, there is going to be a solution. So these challenges are to be well handled by future researchers, and things will be made foolproof. So this is the statement by Jeff Allure, Accelerating Business Growth with Staffing Strategies. He says that generative AI will replace human creativity and jobs. In reality, it is not so. Generative AI is a tool to enhance human creativity, but not to replace it. And so we have to move faster, move in a faster pace with the technology. Otherwise, we will be left behind and the technology will overtake us. So generative AI is the most powerful tool for creativity that has ever been created. It's very true, right? Because we never thought poem can be composed by a machine, a music can be composed by a machine, and a video can be created by a machine, and lessons can be taught by a machine, and prediction can be done by a machine, and then conversation can be done by a machine like chatbot, and then summarization can be done, image captioning can be done by a machine no one ever imagined. So generative AI is the most powerful tool for creativity that has ever been created. It has the potential to unleash a new era of human innovation. So we have to just think of this as a device, as a vehicle with the support of which we will be able to achieve lots and lots of innovations which will be helpful to the society, to the mankind, to education, to research, and the human being, right? So I think I'm done with my presentation. I'll be happy to handle queries if any. Thank you all for your wonderful participation as well as presence, patience. I thank every one of you for being active during the session, for answering the questions, and traveling with me all through. And if there are any specific questions, I'll be happy to handle.
Thank you, ma'am, for an enriching sessions. Participants, the floor is now open for questions. Please feel free to raise your virtual hand or post your queries in the chat box. I repeat, participants.
She has risen, then Ganga Vivek has risen their hands.
Ma'am,
Yes.
ma'am, I'm Pushpa.
Okay.
Ma'am,
Hi,
I
Pushpa.
have doubts in 3 different stages. First one.
There is another voice in the background.
You said about latent space that will generate the pattern from the text data we gave.
Not only text. No. At the time of training, from the large amount of data that is used by the developer, latent space is being created.
Ma'am, is it possible to create the latent space from the images?
Of course, yes.
Okay. Then for a transformer, also you should it will find the data from right.
Transformer is the one which will transform the given data from one format to another format. And it will keep it in the form of encoded form. When there is a question, then it will be able to take from content from this, decode it, and then do it.
Ma'am, if I consider and take an image, means can it able to describe the image? That means futures can be derived from the image using this transformer.
Actually, transformer, when it handles, it will be able to extract the features, not the entire image.
Features. Considering a leaf image, what are the features it can extract, ma'am?
That will be decided by the weightage that is given. Suppose if you take a face as such, right? What should be your attention to identify an object from the face? Eyes, nose, lips. These are all the feature. Face shape. These are all the special features.
Yes.
So neural networks are designed in such a way they will be able to extract the features depending upon the kind of programming that we have, because all the neural networks work on feature extraction, taking the features by themselves, and then they try to use it.
Okay. Then okay, ma'am.
Yes, you can come out with more questions.
I noted it, ma'am, but ma'am, can I have this PPT, ma'am? Soft copy.
Okay, sure. I'll share with the organizers. You can take it. Not a
Yes.
problem. Because I have taken everything from the internet. That is not my stuff. So it is our stuff. I don't mind sharing it.
I mean, even though it's some kind of filtered process because it has a huge of things.
Sure, I share. It's my pleasure. I'll do it.
Ma'am, one more thing, ma'am.
Yes.
It's generating the data. Generative AI is generating some text content based on the questions we give.
Yes.
I created a journal article with the reference from the data generated from ChatGPT. While checking the plagiarism, everything is derived from the online or internet. Then how much the plagiarism rate will be, ma'am?
Actually, nowadays, suppose if you work with Authenticate, there is one component called AI generated content.
Yes,
it will
ma'am.
be able to capture it. So what we should do is we have to take the content, right? The core should be taken and we have to sit and rework so that we are not caught with this AI plagiarism.
99% of data are available in internet. Then it is very difficult to come out
there
of that.
There are certain tools which are available for rephrasing, ma'am. So rephrasing could be done, right? So you can rephrase it, and also we can suppose if there is a kind of translation from one language to another. But because of ChatGPT, we have to translate from ChatGPT English to our English.
Okay.
Okay. So there is no other. Otherwise, no, you will be caught with plagiarism.
Yes, ma'am.
Yes.
Thank you.
Thank you.
Thank you, ma'am, for your queries. Any other queries, participants?
There's one question from Chitra Devi. By using VAE, can we generate medical image for training, whether it is reliable, ma'am? Yes, it is possible. We have to use GAN, Generative Adversarial Network. Using that, you'll be able to generate medical images, but it is not an easy task. We have to train the model. It is perfect. It is possible.
Participants? Any other queries? Thank you. Next, I would like to call upon Mrs. Sakti Mageshwari, our coordinator, to share few words. Ma'am, over to you, ma'am.
Thank you for your taking the time out of your busy schedule to accept a request, ma'am. Today's truly insightful and impactful. Your valuable expertise and presentation on generative AI have provided participants with a wealth of knowledge and practical insights that will greatly enhance their understanding and professional growth. The participants have gained significant learning from your session, which will undoubtedly benefit them in their academic and professional endeavors. Ma'am, your presentation on large language models during the conference at Mary Mother College has greatly inspired our colleagues to pursue a PhD at VIT University, ma'am. Once again, thank you for your valuable contribution. We look forward to more such enriching engagements in the future, ma'am. Thank you,
I
ma'am.
think Sukishri and Priya Karthik have raised their hands. It comes here. I do not know whether. Do you have any questions to be raised? Priya Karthik and Sukishri? Anyway, yeah, I truly believe these kind of sessions should help you to motivate you in the right way.
Yes, ma'am.
To add flavor to your research. That is the whole idea. We have to look into your research in a different perspective, and only then your papers will get published in the good journals. So because you should have innovative component, should have novel component. So essentially, you have to make use of these kind of sessions, and this is only a kind of a drop in the ocean. This generative AI, machine learning, deep learning is a ocean all over again. So I would suggest you to focus on something that interests you and try to make use of this technology and try to publish as many papers as possible before you get the next version of generative AI, right?
Okay, ma'am.
Thank you, ma'am,
Thank you so
for
much.
your enriching words.
Okay. Thank you, the entire organizing team. I thank all the participants for your wonderful participation. You have made the session truly, truly lively. Thanks for that. And again, I was very happy to get connected to Mr. Pakiraj and then Mrs. Mrs. Bindu and Mrs. Shakti or Ms. Shakti, I do not know. So very happy to get connected, you all, right? So all the best to every one of you, dear participants. I thank the organizing team for having provided me a wonderful opportunity to get connected to each one of you through this online, right?
Yes, ma'am.
Thank you, ma'am.
Thank you so much.
Thank you. Good night to all. Bye for now. Let's get connected on some other occasion. Take care. All the best.
Thank you, ma'am. Thank you, ma'am.
Wish you all a very pleasant, prosperous, healthy, and beautiful year ahead. Thank you. Bye.
Bye, ma'am.
I'm signing off. Thanks.
With that, we conclude day 2 of our FDP. Let's meet again tomorrow for another inspiring session. Have a wonderful day ahead. Thank you once again.